Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today in this lecture, we are going to study exercise 7.4 of chapter triangles. Let's have question number 1. Exercise 7.4. Let's have question number 1. Question number 1 says, show that in a right angled triangle, the hypotenuse is the longest side. We are given with a right angled triangle. Let us say this is a right angled triangle which is given. Let's name it A, B, and C. So when I write given, what is given? A triangle ABC, right angled at B. This is given. What we are going to prove? We are going to prove that hypotenuse is the longest side. You know that side opposite to the right angle is hypotenuse. That means in this case this side is a hypotenuse, which I mark it with red. This side is a hypotenuse. So you are required to prove that hypotenuse is the longest side. That means AC is greater than AB, comma BC. This means that AC is greater than AB and BC as well. This is what you are going to prove. Got it? Okay, you can pause the video to make a note. I'll rub it. Now see. This was a triangle A, B, and C. Now proof. First of all, we can say one thing, that's in triangle ABC. Now we say one thing, since angle B is greater than angle A as well as angle C. Why so? Angle B is greater than angle A as well as angle C. Why? Because the reason is that right angle is the largest angle in the triangle. Reason we can write right angle is the largest angle. So that's the reason why we said that angle B is greater than angle A as well as angle C. Now, having said that, which implies that if angle B is greater than angle C, that means the side opposite to angle B is also greater than the side opposite to the angle C. In that case, if you observe carefully, see, the side opposite to angle B is this side. That means this is greater than the side opposite to angle A, and that is BC, this one. And angle B is also greater than angle C. That means the side opposite to angle B, that's AC, is greater than the side opposite to angle C, and side opposite to this angle C is this one. So we came to know that AC is greater than BC as well as AB, and that's it. This is what we were required to prove. So we can write like this. Therefore, angle B is greater than angle A, angle C. That means side opposite to angle B, that's AC, is greater than side opposite to angle A, that's BC, comma, side opposite to angle C, that's AB, and that's it. And reason for this is side opposite to larger angle, side opposite to larger angle, side opposite to larger angle is reason. Then you can write hence proved. Hence proved. Quod erat demonstrandum. Got it? Okay, make a note. Now let's have the next question, question number 2. Question number 2 says, in the given figure, let's draw the figure. It's like this. This is a given figure. A, then I have B, then I have C. This point is P, this point is Q. In the given figure, sides AB and AC of triangle ABC. If I write given, it is given that we have a triangle ABC, a triangle ABC, in which AB and AC is extended to P and Q respectively. So what is given? A triangle ABC in which AB and AC is extended to P and Q respectively. That means AB, here this AB is extended to this point, point P, and here AC is extended to this point, point Q. Okay, now to prove. What we are going to prove, there is one more thing given. Let's write that thing first. This is also given that angle PBC is less than angle QCB. Angle PBC, so that means this angle, is less than QCB, that means this angle. PBC is less than QCB. So I can write in given a triangle ABC in which AB and AC is extended to P and Q respectively, such that angle PBC is less than angle QCB. Angle PBC is less than angle QCB. That is your given. Okay. Now what we are going to prove? Let me rub this. We're going to prove that AC is greater than AB. AC is greater than AB. This is what we are going to prove. Let's have the proof now. What I can do first, I can say since angle PBC is less than angle QCB. Okay, this is already given. What I can do next, which implies that, what I can do next, now see, PBC, look at PBC, can I say PBC, can I make one thing, see, PBC plus this angle ABC is 180 degrees, isn't it? Since it's a linear pair, axiom. PBC, look at the figure, angle PBC, this one, this angle, plus angle QC, plus angle ABC, this one, is going to be 180 degree. Angle PBC plus angle ABC is equal to 180 degree. Can we say that? Yes, we can say that because it's a linear pair. It forms a linear pair axiom. So in that case, if I find PBC here, what is PBC equal to here? 180 minus angle ABC, because if you transpose angle ABC over right hand side, you get angle PBC is equal to 180 minus ABC. So I can replace this PBC as 180 minus angle PBC. Sorry, minus angle ABC. 180 degree minus angle ABC. Then this less than sign as such is less than a QCB. Do the same thing for QCB. This angle plus this angle is 180 degree. In that case, you get angle QCB is equal to 180 minus ACB, isn't it? 180 minus this ACB. So 180 degree minus angle ACB. Can we say that? You can give the reason linear pair axiom. LP in the brackets. Okay. Now next step, you can cancel 180, 180. That means subtracting 180 from both sides. You get negative ABC is less than negative angle ACB. So you get that thing. Make a note for this. I'll rub it out. Now the situation is, which implies that angle negative times angle ABC is less than negative times angle ACB. Angle A, C, B. Let me draw the figure first. Okay, C, which implies that negative times angle ABC is less than negative times angle ACB. ACB. Now multiplying negative 1 throughout. Now pay attention to one thing. This is very important point. Pay attention to this. I'll show you this thing before we go further. The fundamental rule of inequality. Inequality means if x is less than y, this is inequality because this is not an equation. This is inequation. X is less than y. Then if I add something to both sides, suppose I added 1 to both sides, I can do that very well. There is no problem in that. 1 plus x would still be less than y plus 1. So this is correct expression. There is no problem in that. However, again, if you, let's say, you subtract 1 from both sides, again there is no problem in that. Inequality still stands. If I, for example, say multiplying something to both sides, twice x is less than twice y, it's still true, no problem in that. If I divide something from both sides, no problem at all, it still stands. Inequality still stands. That means these are the true expressions. We can do these things. Okay, now having said that, now the point is what we cannot do as far as inequality is concerned. You cannot multiply negative one, negative entity. That means, for example, negative, let's say you multiplied negative 1 to both sides. Suppose. You cannot do that because this is not true now. Let's say, for example, let me give you the specific example. For example, 2 is less than 4. Is this true? Yes, 2 is indeed less than 4. Now, if I add 1 to both sides, what I get? 3 is less than 5. It's again true. No problem in that. What if I subtract 1 from both sides? 2 minus 1 is 1. Less than 4 minus 1 is 3. It's still true. 1 is less than 3. Yes. Now, what if I multiply, let's say, 2 throughout? You get 2 2's 4 is less than 4 2's 8. No problem again. 4 is indeed less than 8. Now, what about if I divide 2 and divide 2 here? 2 by 2 is 1 is less than 4 divided by 2 is 1. Again, it's true because 1 is less than 2. Now, as I said, we cannot multiply negative 1. For example, if I multiply negative 1, this would become negative 2. And if I multiply negative 1 here, this would become negative 4. Now, what's your take on this? Is negative 4 less than is negative 2 less than negative 4? Not at all. Negative 2 is greater than negative 4. Same is the case. So that means we cannot multiply negative number throughout in inequality. Same is the case if you divide something negative. For example, you divide negative 2 here and you divide negative 2 here. Now see, this would come out negative 1 is less than, this would come out negative 2. Now see, negative 1 is not less than negative 2. Negative 1 is greater than negative 2. Now how would you resolve this thing? The rule says, this is a simple rule. Now see what you are required to do as far as these situations are concerned when you do the negative multiplication or negative division from both sides as far as inequality is concerned. What you do, for example, 2 is less than 4. Now, if I multiply negative 1 throughout, I get negative 2 is less than negative 4, which is not true. if I, that means we cannot multiply negative 1. But if we do so, if we multiply negative 1 throughout, we just need to flip this inequality. Flip means now less than would become greater than, and greater than would become less than. So generally speaking, you go like this. For example, you have x greater than y. Now next step, if you multiply negative 1 throughout, that means negative x is less than negative y. Did you get the point now? One more example. If you divide negative thing, that means x is greater than y. That means x divided by negative z is less than y divided by negative z. Provided z is a positive number, because if z would come out negative, then minus is plus, so this whole thing would be positive. Similarly, for example, x is less than y. Now the next step, if you multiply negative 1 throughout, you say negative x is greater than negative y. As simple as that. Hope this makes sense. Now let's come to the question. See, negative angle ABC is less than negative angle ACB. Now if I multiply negative 1 throughout, what I get minus is plus, so negative, so now it becomes plus once you multiply negative 1, so minus is plus, so you got negative, so you'll get negative ABC, negative, you get an angle ABC is greater than. Now since you are multiplying negative 1, you are required to flip this inequality. So flip this inequality, less than would become greater than angle ACB. Got it? Now angle ABC, look at angle ABC. Angle ABC, here's your angle ABC. ABC, this is your angle ABC, this one is greater than angle ACB, is greater than angle ACB, this one. So bold arc is smaller angle. This angle ABC is greater than angle ACB. Now what? You know that side opposite to this angle is greater than the side opposite to this angle. Side opposite to this angle is greater than side opposite to this angle. So in that case, therefore, now which side is opposite to angle ABC? It is AC, this one. So AC is greater than side opposite to ACB, ACB, this one. That is AB. That's it. So this is what you were required to prove. Hence, proved. Got it? Okay. Okay, now let's have question number 3. Question number 3 says, in the given figure, angle B is less than angle A and angle C is less than angle D. Show that AD is less than BC. It's like the similar question. You give it a try yourself. It's the same question. You can do it yourself. Now question number 4, AB and CD are respectively the smallest and longest sides of a quadrilateral ABCD. Show that angle A is greater than angle C and angle B is greater than angle D. Again, it's the similar question. You only need to do in this question number 4, just join the diagonals. I'll give you some idea about question number 4. Question number 3 is simple. You can give it a try. Now question number 4. Question number 4 is, you have figure like this. This is your angle A, then it's B, then C and D. It says that AB and CD are smallest and longest respectively. AB is the smallest of 4 sides. CD is the longest of 4 sides. So this AB is smallest and CD is the longest of four sides. That means you have AB less than BC, CD and AD because it's smallest of all, and at the same time you have CD greater than BC, AB and AD. Got it? So these are the two things which is given. Now you need to show that angle A is greater than angle C. You need to show angle A, this angle, is greater than angle C, this angle, and angle B is greater than this angle. Angle B is greater than angle D. Okay? Now what you can do, you can join the diagonals and you can consider this triangle, triangle ABD, this triangle. Got it? This triangle. Consider this green triangle. Let me use some other color. Let me use some other color. This triangle. If you consider this triangle ABD, you observe one thing, that AB is less than AD. Because it's given that AB is less than this one, AB is less than AD here. So AB is less than AD, that means angle opposite to AB, this angle is also less than angle opposite to AD, that means this angle. So if you name 1, 2, so angle 1 is less than angle 1 is less than angle 2. Got it? Angle 1 is less than angle 2. Then you can do one thing. You consider this triangle, triangle BCD. Let me use another color, this triangle. Now consider this triangle. Here you observe one thing, that CD, this one CD, because it says CD is less than BC here. So sorry, greater than, CD is greater than BC. So you have CD greater than BC. That means angle opposite to CD, this angle, and angle opposite to BC, this angle. This means that if I name it 3 and if I name this 4, so here I get angle 3 is greater than angle 4 because angles opposite to the angles opposite to longer sides are larger. So you have next thing, that is angle 3 is greater than angle 4. Got it? Now if angle 3 is greater than angle 4, this means angle 4 is less than angle 3, isn't it? The simple logic. Okay, if angle 1 is less than angle 2, that means angle 4 is less if angle 3 is greater than angle 4, that means angle 4 is less than angle 3. Now use this inequality and this inequality. Use these two inequalities. Now just add these two inequalities. What you get again, as you are doing addition in equations, in case of equations you add left hand side with left hand side. Similarly you can do in equations, you add left hand side with left hand side and right hand side with right hand side. That means what is left hand side to this inequality? Angle 1 plus angle 4. That means you get like this, angle 1 plus angle 4 equal to angle 2 plus angle 3, isn't it? So you get this thing, angle 1 plus angle 4 is equal to this plus this and this plus this. Not is equal to, sorry, it is less than, angle 1 plus angle 4 is less than angle 2 plus angle 3. because you are doing addition in inequality. So this plus this is less than this plus this. Angle 2 plus angle 3. Okay. Now look at the figure. Angle 1 plus angle 4. Angle 1 plus angle 4 is nothing but this whole angle. Is less than angle 2 plus angle 3. Angle 2 plus angle 3 is nothing but this angle. So what you got? Angle 1 plus angle 4, that means whole angle D. Angle D. So you have angle D now. In that case, you'll get angle D because 1 plus 4, that's angle D, is less than angle B because 2 plus 3 is angle B. And here you can write, therefore angle B is greater than angle D. Since angle D is less than angle B, that means angle B is greater than angle D. That's it. This was the one thing which you were required to prove. Similarly, you can prove angle A is greater than angle C. How? By joining this diagonal. Now once you join this diagonal, do the similar thing and you'll get, inshallah, angle A is greater than angle C. Hope this makes sense. Now let's have the next question. Let's have question number 5. Question number 5 is most important question, one of the most important questions of this chapter. It says, in the given figure, we have a given figure. Let me draw one. In the given figure, PR is greater than PQ. Now triangle is P, then I have Q, then here I have R. PR is greater than PQ. This one is greater than PQ, so this one is smaller. Okay. And PS bisects angle QPR. Angle QPR is this angle and PS bisects this angle. So let me draw PS. This is PS. PS bisects this angle, that means this angle is equal to this angle. In that case, you can say angle QPS is equal to angle RPS. Okay. Now you need to prove that angle PSR. PSR. So this angle is angle PSR. You need to prove that this angle is greater than angle PSQ. This angle is greater than this. You need to prove this is greater than this. This must be smaller. But you're required to prove this. So this is a question mark. You're required to prove that angle PSR is greater than angle PSQ. Got it? Now you can write given let's write given. What is given? A triangle PQR, a triangle PQR in which PR is greater than PQ. PR is greater than PQ and PS bisects angle QPR. Okay, QPR. Got it? Now as far as to prove is concerned, what we are going to prove? We are going to prove angle PSR is greater than angle PSQ, is greater than angle PS, is greater than angle PSQ. This is what you are required to prove. You make a note, I'll drop this out. Okay, now see. And now let's have proof now. Proof. First of all, I can do one thing. Let us use exterior angle property. What does it say? That exterior angle of a triangle is equal to sum of two interior opposite angles. Like for example, let's use angle PSR. See, this angle in triangle PQS. So I consider this triangle. In this triangle, I have this angle equal to this angle plus this angle, which I marked by yellow. So this is exterior angle property, that exterior angle of a triangle is equal to sum of two opposite interior angles. Okay, now let's see afterwards what we can do. So angle PSR is equal to angle QPS plus angle, let me name this 1 and 2. Okay, so I can write since, so I would write since or let's write first in triangle PQS, since angle PSR is equal to angle 1 plus angle 2. Okay, angle 1 plus angle 2, this is nothing but exterior angle theorem, EAT. Got it? Now similarly, if you consider this triangle, this green triangle which I showed by green, this one, in this triangle what you observe, you have this angle equal to this angle plus this angle, again exterior angle theorem. So you can name this as 3 and this as 4. Got it? So you can write similarly angle PSQ, angle PSQ. Similarly, angle PSQ is equal to angle 3 plus angle 4. This is again exterior angle theorem. That's why I wrote similarly. Now pay attention. You can do one thing, that angle, you know that angle 1 is equal to angle 3 because PS is an angle bisector of angle QPR. So you can make one thing, that angle 1 is equal to angle 3. So you can replace this. You can write, which implies that angle, so I can write angle PSQ as such is equal to, now replace angle 3 by angle 1 because angle 3 is equal to angle 1 as PS is the bisector, plus angle 4 as such. Now here you can write the reason as PS as PS bisects angle QPR. Angle QPR. Or you can write like this. There's a little space here. Let me rewrite this. Reason is as PS bisects angle QPR. QPR. This is the reason. Okay. This is the reason why I replaced angle 3 by angle 1. Now the situation is angle PSR here. Look at this situation. Angle PSR is equal to angle 1 plus angle 2, and here you have angle PSQ is equal to angle 1 plus angle 4. Now you can do one thing. Let's find angle 2 and angle 4 in both the cases. Remember this. In this case, you can find angle 2 is equal to angle PSR minus 1, and in this case angle 4 would be equal to angle PSQ minus angle 1. Okay, simple. Let me repeat this. In this case, angle 2 is equal to angle PSR minus angle 1, and in this case angle 4 is equal to angle PSQ minus angle 1. Now make a note. Let me rub this out. Remember this. I will write it here. Let me write it here. Angle PSR is equal to angle 1 plus angle 2, and angle PSQ is equal to angle 1 plus angle 4. Now let me rub this. Now pay attention. Now you can say one thing, that PR is greater than PQ. This is given. You can check given. This is already given that PR is greater than PQ. If PR is greater than PQ, that means in triangle PQR, in whole triangle PQR, you have angle opposite to PR greater than angle opposite to PQ. Which is the angle opposite to PR in PQR triangle? This is PR. The angle opposite to PR is nothing but angle Q, or angle 2, you can say. Angle 2 is greater than, which angle is opposite to PQ? That is angle 4. You check the figure, that is angle 4. Okay, you can give the reason. Angle opposite to longer side. Angle opposite to longer side. Okay, now which implies that now angle 2 is greater than angle 4, which implies that now you can write angle 2 as angle PSR minus angle 1 here. Angle 2 is equal to angle PSR minus angle 1, so you can write angle PSR minus angle 1 is greater than angle 4. You can write angle 4 here, angle 4 as angle PSQ, minus angle 1. Angle PSQ minus angle 1. Okay. Now adding angle 1 to both sides, this and this gets cancelled. You can add angle 1 to both sides, and hence angle 1 from left hand side and negative angle 1 from right hand side, it gets cancelled. So you're left with angle PSR is greater than angle PSQ. Angle PSR is greater than angle PSQ. Therefore, angle PSR is greater than angle PSQ. And that's it. This is what you were required to prove. Hence, proved. Quod erat demonstrandum. Okay. Now the last question. Question number 6. It says show that of all line segments drawn from a given point, not on it, the perpendicular line segment is the shortest. So of all the line segments drawn from a given point, the perpendicular distance is the shortest. This is a very simple question. You can do like this. This is a line and this is a point. Now if you draw all line segments from this point to this line, so for example this, of all these line segments, the perpendicular one would be the shortest. This is what you are required to prove. This is very simple. Now you can do one thing. If for example say this is O and let us say this is line L, let's say this is point P and this is P1, this is P2, this is P3, here P4 and here P5. Okay, now you can do one thing. If you consider triangle OPP1, what you observe here, that angle OP, this angle is the right angle, and right angle is the largest angle possible in a triangle. So that means this segment OP1 is less than this segment, sorry, greater than, because side opposite to the larger angle is longer. So OP1 is greater than OP. Similarly for triangle this side is greater than this. Similarly for all the triangles, every time you get this line segment, this is a hypotenuse for the triangle, and every time this length shown by red, this length is always the shortest length, which proves your result that line segment drawn from a point to the line, out of all the line segments, the perpendicular is the shortest. Hope this makes sense. And alhamdulillah, by this we are done with this chapter, triangles. See you next time, inshallah, with some new stuff. Till then, take care. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.